We're going to use a definition of the derivative to differentiate f of x equal to sine of x squared. Now recall the definition of the derivative f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. We're going to need three results to make computations easier. The first is trig identity sine of a plus b equal to sine of a times cosine of b plus sine of b times cosine of a. The second result we'll need is the limit as y approaches 0 of sine of y divided by y equals 1. And the third result, another limit as y approaches 0 of cosine of y minus 1 divided by y equal to 0. Finding the derivative by definition is a four-step process. So let's begin with step number 1, and that is to compute and simplify f of x plus h. In our case, it is sine of x plus h quantity squared, which can be expanded, and it becomes sine of x squared plus 2xh plus h squared. It's a sum of three things. We'll call the first one a, and then the sum of second and third, we'll call that b. And let's use the first result that we needed, the trig identity. So this becomes sine of a, that's sine of x squared, times cosine of b, which is cosine of 2xh plus h squared, plus sine of 2xh plus h squared times cosine of x squared. And that's all we need to do in step number 1. To go to step 2, in step 2, we compute f of x plus h minus f of x. So since we just computed f of x plus h, this is pretty easy. This is sine of x squared times cosine of 2xh plus h squared plus sine of 2xh plus h squared times cosine of x squared and minus the function f of x, which is sine of x squared. Now notice that the first term here and the third term have sine of x squared in common, so before going to step 3, we're going to factor out sine of x squared, and that's times cosine of 2xh plus h squared, and that's minus 1, plus sine of 2xh plus h squared times cosine of x squared. And that's the end of step 2. Let's go to step number 3. And that's when we take the result of step 2, f of x plus h minus f of x, and divide that by h. So this will become sine of x squared times cosine of 2xh plus h squared minus 1, and that's divided by h, plus the second part of f of x plus h minus f of x. That would be sine of 2xh plus h squared times cosine of x squared, also divided by h. Now note that 2xh plus h squared equals to h times 2x plus h. So the next step is to multiply and divide everything by 2xh. This is what it will look like. We have not changed the problem. So this will look like this: sine of x squared times cosine of 2xh plus h squared minus 1, and then times 2x plus h, and in the denominator we have h times 2x plus h. Multiplying and dividing by the same thing does not change the problem. Plus sine of 2xh plus h squared times cosine of x squared, and that times 2x plus h, and that's divided by h times 2x plus h. And let's rewrite this one more time. And this looks like this now. Sine of x squared times cosine of 2xh plus h squared minus 1 times 2x plus h, and in the denominator h times 2x plus h is 2xh plus h squared, plus sine of 2xh plus h squared times cosine of x squared times 2x plus h, and that also is divided by 2xh plus h squared. Now our next step is to do the following. We're going to let y equal to 2xh plus h squared, and note as h approaches 0, y also heads to 0. That's important. We're now ready to go to step 4, but before we do that, let's rewrite this one more time. The end of step 3 looks like this: sine of x squared times cosine of y minus 1 times 2x plus h, and that's divided by y, plus sine of y times cosine of x squared times 2x plus h, and that's divided by y as well. Let's go to step 4. In step number 4, we find the derivative. So step 4 is when we actually evaluate the limit. F prime of x is the limit as h approaches 0 of f of x plus h minus f of x divided by h. We already computed everything we need, so all we have to do is take the limit. Since we have sine of x squared, it does not depend on h or y. We can just factor it out. So we have sine of x squared out in front, and then we have the limit as y approaches 0, because that comes through from h, of cosine of y minus 1 divided by y times the limit as h goes to 0 of 2x plus h, and then followed by the limit as y approaches 0 of sine of y over y times the limit as h approaches 0 of 2x plus h, and then times cosine of x squared. So let's recall right here, that's result number 3. That limit of y going to 0 cosine y minus 1, that limit is heading to 0. That limit is 0, so the whole first part is going to be 0. Sine of x squared times 0. This limit here that I'm underlining will go to 2x, so sine of x squared times 2x times 0 is heading towards 0. In the second part, this is heading toward 1. The limit as h goes to 0 of 2x plus h is heading to 2x. And of course, cosine of x squared is not affected by either y or h. And so what we have left after taking the limit is 2x times cosine of x squared, which is the derivative of the function. So let's summarize what we just did. The summary is we started with the function f of x equal to sine of x squared. And by definition of the derivative, we show that the derivative of this function is equal to 2x times cosine of x squared. For